Okay, we're on 7.3 day 2, angle relationships in polygons. I want you to first notice as a change I made here. So change your second equation to 3x minus 2y equal 4. What I'd like you to do is once you've changed that is to try this on your own to see if you can do it because it's great exam preparation. I'm not going to review that with you because it should be self-explanatory with the answer there, but I will expand this answer so that you can pause the video later and see the answer a little more clearly with the check involved. Okay? But again, I would like you to try that on your own and see if you can figure that out, and then of course use the video as your guide. All right, draw and label an example of the shape below or explain why it's not possible. So this is asking us to create a triangle with one acute exterior angle. So an acute angle, in this case, means less than 90 degrees. So we can create an acute exterior angle. That would just mean that my interior angle has to be obtuse. So let's try this, and we'll do that. So now I have an obtuse angle. And of course, if I were to continue this line out here, then this line here would be this angle would be less than 90 degrees, and oops, sorry. And of course, this angle right here would be greater than 90, or an obtuse angle. Let's look at this. Now, if I join the triangle together, I've got one acute exterior angle, because that's less than 90 degrees, and then this interior angle here has to be less than 90, and this interior angle here has to also be less than 90. And the reason is because this angle inside right here is greater than 90, and we know the sum of the interior angles of a triangle equal 180 degrees. So if I labeled this triangle A, B, C, we know that inside that triangle, C is greater than 90. C is greater than 90 degrees. And then that would leave us less than 90 degrees to less than 90 degrees for the other two angles, for this angle here and this angle here. So the sum of those two angles is 90, but each one on its own has to be less than 90. So let's look at the exterior angle at A and B. Let's erase this to get some clarity. Not that much. All right. So if I look at the exterior angle here, the exterior angle here we said was less than 90, and the exterior angle here is greater, and then of course the exterior angle at B is also greater. So we have created a triangle that has one acute exterior angle. So I've given you the reason why to create one acute exterior angle, the supplementary, again remember supplementary just means this. You have two angles, let's call this X, let's call that Y. These two angles together add up to a 180 degrees. And that's what you really get over here. Let me just change that color. That's what you get over here. You get a supplementary angle. And I can call this interior one X and that one Y. But they add up to 180. Okay? Okay, so to create one acute exterior angle, the supplementary angle inside the triangle would be greater than 90 degrees, or obtuse. The other two interior angles would have a sum less than 90 degrees. Each would be less than 90 degrees. Therefore, the other two angles would have supplementary exterior angles that are obtuse. So this is possible. That's just the formal way of writing what I explained to you with words. Find the sum of the interior angles of each polygon. So let's try that. We have a four-sided shape here. If this is four sides, then we know that the sum of interior angles is equal to 180 times n minus 2. And in this case, we have the sum of interior angles equaling 180 times 4 minus 2, which is 2. So the sum of the interior angles is 180 times 2, which is equal to 360 degrees. So the sum total of those angles is 360 degrees. Let's look at this one right here. We have one, two, three, four, five sides. And it's not a regular polygon because a regular polygon would have all equal sides. But in this case, we still do have 5 equal sides. So the sum of the interior angles of a 5-sided shape would be 180. Again, the number of sides is 5 minus 2. So the sum of interior angles is 180 times 5 minus 2 is 3. We know 180 twice is 360, and add another 180. Oops. So we get 460 plus another 80, which is 540. Let me just move this down. So the SIA equal 540. Move to this one here. And now we have 1, 2, 3, 4, 5, 6, a 7-sided shape. So the sum of interior angles is equal to 180 times 7 minus 2, which is 5. So the sum of interior angles is really 180 times 5. That gives us 900. So the sum of interior angles here is 900 degrees. And I should have written degrees here as well. All right. Here it says draw. This is just taking a look at 7.4, getting a quick look ahead. Draw and label the right bisector. A bisector is a line that cuts equally in two parts. Bi means two, or bisect means cut equally in half. So in this case, if I were doing a right bisector, it's a perpendicular bisector, it would cut evenly in half at a 90-degree angle. So something like this. I have to move it over a little bit more. Something like that, where that's a 90-degree angle, and this side is equal to that side. If I were doing that over here in this triangle here, it would be something like, oh, not exactly like that, but you get the hint, something like this. And then that would be 90 degree here, and that would be 90 degree there. And of course, this side would be equal to that side. So I'm labeling it to show you that those two parts are cut in half. Now, if I have A and B there, I might call this D. So I know that AD is equal to DB. Okay, that's important to show. And here, if I'm drawing the perpendicular bisector or right bisector of line segment AB, I would just count 1, 2, 3, 4, 5. So at the 2.5 mark, which is about there, I would have to draw a straight line, perpendicular line. There we go. Close enough. Okay, so that'd be a right angle, and this side would equal that side. Here, we're going to be drawing it on an angle. So I'm looking at 1, 2, 3, 4, 5, 6, 7. That goes over 7. So at the 3.5 mark, 1, 2, 3.5 mark, somewhere around here is where I'd be drawing my 90-degree angle. So my right angle would look something like, not like that, oops, something like this. Okay, and that's 90 degrees there, 90 degrees there, and that angle, that side equal that side. Here, we would have a straight down the middle again, and I call that D. AD is equal to DB, and that is a right angle. So you need to show the right angles. I didn't need to show two there. You need to show that it's right angle and that the line, the bisector, cuts the line AB in two equal parts. Okay, that's just a quick look ahead, and that's it. We'll see you in class.